Good morning, students. Today we'll talk about one more form of differential equation, that is linear differential equation. Let's begin with, we have differential equation chapter is there for maths, for class 12th in maths chapter 9th. So now we'll discuss about the linear differential equation. Okay, linear differential equation. Linear differential equation. Now, let us talk about this. The form of the linear equation is dy upon dx plus py is equal to q, where p and q are constant, or we can say they are the functions of x. Now, what we will do, let us try to do some examples, or we can say I can say just try questions from exercise. Let us see how this forms works, how we are able to find the find the general solution of this type of equation. So now we have the first question in my hand, that is dy upon dx plus 2y is equal to sin x. Okay, first we have to consider this form must be there in the differential equation, and that form is called linear differential equation. Now, after doing that, let us see, we have here p is 2 and q is sin x. After identifying, we have to find the integrating factor. How we find the integrating factor? That is e s power integration of p dx. We have 2 dx. So what we can do here? Take 2 outside. So we have e raised power 2x. So I got my integrating factor here. Now after that, what I will do? Multiply it by y. Integrating factor is equal to integration of q. What is q here? Sin x into integrating factor. Okay, so here these are the steps which we have to follow in every question of linear differential equation. Now let us try to solve them. Okay, so we have what I will consider first, we'll integrate this as by parts. This is I. Okay, so let us try to solve by parts. Here I am taking e raised power 2x as a first function. So e raised power 2x. Now integration of sin x will be minus cos x minus. Now integration, differentiation of first function, we have, that is e raised power 2x will be e raised power 2x. Okay, and 2x, if I take this t as 2x is equal to t. Okay, if I take tx equal to t, so we have, okay, so this is what we have. Now we'll take half as common, and integration of sin x will be cos x, so it will be plus cos x dx. So again I have to integrate this. Okay, so I have minus e raised power 2x cos x. Okay, let us see. Now let us try to solve it again. Plus half is there. Now take this as first function again, this is as second function again. So now e raised power 2x sin x, we all know the integration of cos x will be sin x. Now we have minus differentiation of first one, again I will have e raised power 2x and it will be sin x dx. Okay, so again I have done this. Now I got this much minus half differentiation integration of sin x. Okay, so now we have this e raised power 2x. Okay, so now we can consider this. Again we have Now let us see what we can do here. We have e raised power 2x cos x plus, if I take this, uh, it will be e raised power 2x sin x by 2 minus 1 upon 4. And what is this e raised power I? So I will take this. We have I. Okay, and now we have this I and I. So what I will do here, I will take here I plus 1 upon 4 I is equal to minus e raised power 2x cos x plus e raised power 2x sin x upon 2 I have. Okay, so now 4 plus 5 upon 4 I is equal to, what we can do here, we have 5.4 I minus, if I take the LCM here, so 2 e raised power 2x cos x plus e raised power 2x sin x. Okay, so I have 2 here, so eliminating this by 2. So now I will take this at that side, so I will got I is equal to 2 multiplied by 5. So I will got here minus 4 e raised power 2x cos x plus 2 e raised power 2x sin x. Okay, so we have this, and upon I have 5. Okay, now I will put this value here. So I will got y e raised power 2x minus, no, it's supposed to is equal to, this will have minus 4 e raised power 2x cos x plus 2 e raised power 2x sin x upon, we have 5. I can take e raised power 2x common, it will be reduced. So therefore I got y is equal to, we can take this 2 e raised power 2x, sorry, now e is reduced, so we have 2 sin x minus 4 cos x upon 5. Okay, so that is how we able to find the general solution of this linear form of equation. Now let us try more examples or more numericals from this exercise. Okay, so we have done first, now let's try second one. Okay, now what the second says, let us see. Now we have the question second, that is dy upon dx. Second question I have dy upon dx plus 3y is equal to e raised power minus 2x. They have given this. So now what we have here, p we have 3 and q we have e raised power minus 2x. Now let us try to find the integrating factor, that is e raised power p dx. Here we have e raised power 3, we'll take outside, we have dx, so we'll have e raised power 3x. Now multiply it with y here and integrate it with q. We have, what is q? 2x into e raised power 3x dx. So we have y e raised power 3x is equal to e raised power x dx. So we have y e raised power 3x is equal to e raised power x. Okay, we have plus c here. Okay, so we have this, we can reduce it, we get y is equal to e raised power x upon it will be minus 2x plus c e raised power 3x. So you can see e raised power minus 2x plus c e raised power minus 3x. Okay, so that is how we able to find the general solution of the linear differential equation. Now let us try with the third question now. I hope it's clear to you how we able to find the general solution of the linear differential equation. Now we have the third question I have, that is dy upon dx plus y upon x is equal to x square. Okay, so now we understand this, that we have p, that is 1 upon x, and q we have x square. Now first step is find the integrating factor, that is e raised power p dx. So we have e raised power 1 upon x dx. We have e raised power log x, or you can say x. Okay, as we know, e raised power fx will be integration of this will be e raised power will we have fx. Okay, so now multiply the integrating factor with y is equal to multiply here with the q dx plus c. So I have y into x is equal to x cube dx plus c. Now y into x we have x4 by 4 plus c. I reduce it, so therefore I got y is equal to x cube by 4 plus c. Okay, so that is how we find the find the general solution of the linear differential equation. Okay, so now let us try to solve the fourth question. Now we have just solved only three. Now let us see how we are able to solve the fourth question. Now we have the fourth question here. dy upon dx plus sec x y is equal to tan x. Okay, now we know that we have here x value, x lies between 0 to pi by 2. Let us see how we can do it. Here we have p, that is sec x, and q we have tan x. So let us try to find the integrating factor first, that is e raised power p dx. So we have e raised power sec x dx integration. So we have e raised power, that is, now we know that the integration of sec x will be log of sec x plus tan x. So we'll get sec x plus tan x. As we all know that the integration of, if I say e is power log of fx will be fx. Okay, so we are using it. Now multiply the integrating factor with y. Sec x plus tan x is equal to integration of, what do we have, q here, tan x. So we have tan x into sec x plus tan x dx. Now leave this as it is, sec x plus tan x is equal to, now we will multiply here, that is tan x sec x dx. I am separating it out, so we got tan square x dx. So we all know, now I am putting this plus c. So we have, so we all know integration of tan x sec x will be sec x plus tan square x, second right as sec square x minus 1, because we can't integrate tan square x's directly, so we'll use the formula. Now we have sec x plus integration of sec square x will be tan x and minus 1, that will be minus x plus c. We have sec x plus tan x. Okay, so I got this, that is the general formula of the linear differential equation. Now let us try to solve more questions. Now we have just solved 4. Now let us try to solve 5th one. Now 5th numerical we have, what I have 5th, that is they have given, that is 5th is equal to cos square x dy upon dx plus y is equal to 10x. Okay, here also x lies between 0 to pi by 2. Okay, so now what do we have to do? We have to make it in a linear differential equation form. How? Divide whole by cos square x. So I got dy by dx plus 1 upon cos square x will be sec square x y, okay, and is equal to tan x upon cos square x. Okay, so we have tan x upon cos square x. Now we have p here, that is sec square x. Q here we have tan x upon cos square x. Okay, so we have this. Now we'll try to find the integrating factor, that is e raised power integration of p. So we have, what is p? We have this sec square x dx. We all know the integration of sec square x is 10x, so I can say e raised power 10x. So multiply with integrating factor with y is equal to, here I will multiply q, we have 10x upon cos square x into e raised power 10x dx. Okay, here now we want to solve this plus c. Okay, so this is I. Let us see. Now we all know 1 upon cos square, so I can write this tan x into sec square x. Okay, so now we'll put this here. So what I can see, instead of writing here, we'll write as sec square x tan x. Okay, now what I can see, let us try to integrate this first. So we have sec square x tan x e raised power 10x dx. Put tan x is equal to t, so we have differentiating tan x, we know sec square x dx is equal to dt. Okay, so here I have sec square x dx will be dt and e raised power t into t we have. This now we have. Okay, so it becomes easier for us to solve. So now what we can do, we'll take this as first function, this as, no, take this first function, second function. So we'll have t e raised power t minus difference of t e raised power t, and we have e raised power t plus c. Because we know by parts we have done, if I integrate this differentiating first function, t will be 1 and integrating et will be e raised power t dt plus c. So I can say t e raised power t minus e raised power t. So I have just solved this. Now I can put the value here. What we have taken t I have taken tan x, so I can put tan x e raised power tan x minus e raised power 10x. So now what we can do, put this value here, put this value. So I got y into e raised power 10x is equal to tan x e raised power 10x minus e raised power 10x plus c. You can take common from here and reduce it. So we got I is equal to tan x minus 1 plus c. Okay, so that is how we able to find the general solution of the linear differential equation. Okay, so now let us try to solve the sixth question we have. We have just solved only 5. So let us try to solve the sixth question here. So now what the sixth question is, let us see. We have sixth question, that is x dy upon dx plus 2y is equal to x square log x. Okay. First step is to make the linear form of differential equation. We'll divide by x. So I got dy upon dx plus 2 upon x. Y is equal to x log x. Now we all know we have p 2 upon x and q we have x log x. Okay, so now find the integrating factor, that is e raised power integration of px p. So we have taken 2 1 upon x dx. So now we have 1 upon x, so we can say e raised power 2 log x. We can write e raised power log x square, it becomes x square. Okay, so now we all know that is e raised power integration of fx will be fx. Okay, so I have this. Now I can write this as y into integrating factor, integration of 2 into integrating factor. Now let us try to solve. This is I, so I will be solved as x cube log x dx. What we'll do, take this as first function, second function. Differentiation of log will have log x into x cube by 4, x4 by 4 minus differentiation of x cube will be 3x square into wait. We have taken the first function log x now. So differentiation of this will be a 1 bond x. Integration of x cube will be x4 by 4. So we have log x into x4 by 4 minus, if I reduce this by 3, I got 1 upon 4 into x4 by 4. So I got here log x into x4 by 4 minus x4 by 16. We'll put this value here. So I got log x plus x4 by 4 minus x4 by 16. And here we have y into x square. So now what we can do here, we'll divide by both. So y is equal to, we have, if I divide in here, what I got here, we have 1 upon x square log x plus we have x square by 4 minus x square by 16 plus c. Okay, so we can reduce it. We have x square here also. So that is how we able to find the general solution of the different linear differential equation. Let us try to solve more. We just have solved only 6 questions. Now we'll try to solve the 7th. 6 questions I have just solved. Now let us see how I able to solve the next question, that is 7th. Now they have given the 7th question. I have x log x dy upon dx plus y is equal to 2 upon x log x. So first of all, try to make it in the linear differential equation form. So we have dy upon dx plus 1 upon x log x. Okay, we have y is equal to, now if I divide by this, log x by log x will reduce, we'll have 2 upon x square. So we have p is equal to 1 upon x log x and q is equal to 2 upon x square. Okay, so first what we will do, we'll try to find the integrating factor. What is e raised power p dx? So we have e raised power dx upon x log x. Okay, so now let us try to solve this. Okay, now let us try to solve this. We can take 1 upon log x as t, 1 upon log x as t, or simply I can take log x is equal to t. So we have 1 upon x dx is equal to dt. So we have 1 upon t, that is log t. So we'll got this e raised power log of log x. Now I got log x. Okay. So finally I able to find the integrating factor. Now multiply it by y, and here I got log x into 2 upon x square dx. Okay, plus c. So this is I. So let us try to make it. That is I. Now we'll take 2 common. We have log x into 1 upon x square. Now we'll integrate it by the chain rule. That is, consider log x as first function and 1 upon x square as second function. So we'll have log x. Now 1 upon x square minus 2 plus 1 as will be minus 1. 1 upon x will be there. Okay, minus 2 minus 1 will be there. So this is now minus. Now differentiation of log x will be 1 upon x, and integration of this we have 1 upon x. So it will be minus. Okay, we got this. Again, now what we need to do, minus 2 upon x log x plus 1 upon x square dx. Okay, so now we have this. Again, if I solve, I got minus 2 upon x log x minus 2 plus 1. We will have minus 1 upon x. Okay, this one. Okay, so that is what I got here. We'll put this value where? Here. So I got y log x is equal to minus 2 of x log x minus 1 upon x. Okay, plus c. We have this. So we can take here, if I say minus common and reduce it. So we have minus 2, we have taken minus sign common. So we have log x minus 1 upon x, 2 log x. We have plus 1 plus c. Okay, so we have log x plus 1. We have taken the x as LCM and minus sign also common. So I have this. So I got, if I reduce, I got minus, it will be minus 2 log x plus 1 upon x into log x. Okay, I have this plus c upon log x. So finally I able to, if I reduce this, if I got minus 2 upon x plus, so if I multiply minus sign inside, I will got x log x plus c upon log x. So this is the required general solution of the given linear differential equation form. Okay, so now let us try to solve more. I have solved only 7 numericals. Now let us try to solve 8 numerical. Now we have the 8 numerical here, that is 1 plus x square dy upon dx. No, we have not this. Okay, dy plus 2xy dx is equal to cot x dx, where x is not equal to 0. And plus x square dy plus 2xy dx is equal to cot x dx. Now what we can do here, we need to make it in that form. Okay, so now divide by dx here. First dx dy upon dx plus 2xy is equal to cot x. Okay, then again what we need to do, divide by 1 plus x square. So we have 2x upon 1 plus x square, y is equal to cot x. Now we have p, that is 2x upon 1 plus x square, and q we have cot x. Okay, so we have this. Now we'll try to find the first integrating factor. So we have the integrating factor here, it is e raised power dx. So we have e raised power 2x upon 1 plus x square dx. Now we can solve easily. Take 1 plus x square is equal to t. Okay, so that 2x dx is equal to dt. So we have e raised power dt upon t. Again I have e raised power log t. Okay, now 1 upon t, log t we have. So now what is log t? T we have 1 plus x square. So I got 1 plus x square as an integrating factor. Okay, we know that e raised power log x is equal to x. Now what we can do here? Just multiply. Okay, so now I got here q we have integration of, we have 1 plus x square cot x dx. So now 1 plus x square is equal to, what we can do? Simply we can do it like this, 1 plus x square cot x dx. Okay, so we know that cot x will be log of sec x, plus here again I need to put the value x. Okay, so we have, now we'll try to solve. We have divided by s and we got here 1 plus x square. So we have 1 plus x square we have. So now what we have here, that is 1 plus x square. So I can put here 1 plus x square. So I got this. So I have this only. Okay, and to write we have dx. Okay, this we have done integrating factor. Now we have cot x, that is log of sec x plus c. So now we can have this. Okay, so this is, so we have this, that is log of sin x plus c. So this is the general solution. Okay, so this is a general solution of the given linear differential equation. Okay, so now let us try to solve ninth. We have just solved only 8. So now we'll try to solve the ninth question now. What we have? The ninth question. So what they have given in this, in ninth question I have, that is x dy upon dx plus y minus x plus xy cot x is equal to 0. So a lot of things they have given. So let us try to solve first. Now they have given this. We can take this on that side. So x dy upon dx plus y is equal to x minus xy cot x. Okay, so now reduce it by x. So we got dy upon dx plus 1 upon x, y, if I take x common and reduce by 2, so I got 1 minus y cot x. Okay, so I have that is 1 minus y cot x. So here I have p that is 1 upon x and q that is 1 minus y cot x. Okay, so I have this. Let us see how we can do it. Now what we can do here, instead I can use this, that is y1 plus x cot x, okay, is equal to x. I've taken x that side. Now when I reduce it, so I got here 1 upon x plus cot x y is equal to 1. Okay, so now we can say we have p is equal to 1 upon x plus we have cot x and q we have 1. Okay, so now what we can do here, first try to find the integrating factor. So now integrating factor I have e raised power 1 upon x plus cot x dx. Okay, so now we'll try to solve. If I try to solve this, I got log x plus we have cot, we got log of sin x. Okay, so that we have. Now in this I can take log a plus log b will be log a into b, and we all know p as per log of fx will be fx, that is x sin x. So finally I got my integrating factor. So we'll apply here y into integrating factor is equal to integration. What is we have q? We have 1, so we can multiply. So we can get x sin x dx plus c. Okay, because we have y1, so we have q1. So now we can integrate, take first function as second function. By parts we'll do I is equal to x into cos x minus differentiation of x will be 1 and sin x will be minus cos x plus c. So I got minus x cos x plus sin x. Okay, so now put this value here. So I got y is y into x sin x is equal to minus x cos x plus sin x plus c. Okay, so that is what I got, the general solution of the given linear differential equation. In this we can do more by dividing. So we got minus cot x plus 1 upon x plus c upon x sin x. Okay, so this is the required general solution. Now let us try to solve the 10th question. We have just solved only 9. Let us try to solve 10. We have just solved 9 numericals today. Now let us try to solve 10th one. So now I have the 10th question. They have given, that is x plus y dy upon dx is equal to 1. How we do? We have to make it in the form, that is linear differential equation. How? X dy upon dx. Okay, then x plus y we have. If I multiply here y dy upon dx is equal to 1 we have. Now what else? What we can do here? We have 2 dy by dx here, no? So now we have to see what we can do. Instead, if I take this down, dx plus, if I say is equal to 1 upon x plus y here. Okay, let us see how we can do it. Let us try to solve in a very different way. Okay, let us see how we can do it. This equation dy upon dx is equal to 1 upon x plus y. Now if I write it dx upon dy is equal to x plus y, we can take what we can take here, dy dx upon dy minus x is equal to y. So we have p minus 1, we have y. Now first find the integrating factor, e raised power integration of p dy. Here we have minus dy. Okay, so we'll have e raised power minus y. Okay, so after finding the integrating factor, multiply it by y, minus y into e raised power minus y into y is equal to integration of q. What is f q? Y into e raised power minus y dy plus c. Okay, now take this as first function, second function. So we have y into integration of e raised power minus y dy minus differentiation first. We have 1 into integration of this. So we have e raised power minus y dy. So we have minus y e raised power minus y minus e raised power minus y. Put this value here. So I got e raised power minus y into y is equal to minus y e raised power minus y minus e raised power minus y plus c. We can take common here. So I got y is equal to minus y minus 1. Okay, now it multiplies plus c into e raised power y. Okay, so that is what we can easily find the general solution of the given linear differential equation. Now let us try to solve more. Today we have just solved only 10. Let's try to solve 11th. Now we have 11th question. So now let us try to solve 11th. I hope it's clear to everyone. So now we'll move to the 11th question. Now they have given the 11th question, that is what we have, y dx plus x minus y square dy is equal to 0. So they have given this, how to make it, what we can do here, divide by, if I say y dx is equal to minus x minus y square dy. If I take this dy upon dx, we got x minus y square. Okay, we have this. If I separate it out, what else we can do here? Let us see how we can do this. Let us try to solve it. What we can do here, now a simple way, if I say y square minus x dy and divided by y. Okay, so now we have this y square minus x upon this. So if I reduce this, I got dy upon dx is equal to y minus x upon y. We have this. Okay, if I've done this, why I'm taking this now. We have taken y here, so I got this. So what I can do, dy upon dx minus x upon y is equal to y. So we have just done this. So let us see how we can do it. Now let us try to solve this. What I got here, that is dx upon dy. Okay, so I got this dy. So now here I have p minus 1 upon y and q y. Let us try to find integrating factor, y raised power minus 1 upon y dy. We have minus log of y raised power minus log of y, we got minus y. Now multiply with minus y and y is equal to minus y But we have q here. We need to take care of q. So we have q is, we have taken here y dy. So we have minus y square is equal to integration of dy. So we have, so we can put value here. This value we'll try to put here. So we got this minus y square is equal to minus y cube by 3 plus c. So if I say, if I reduce this by y, so I got minus y is equal to minus y square by 3 plus c upon y. Take it as minus sign, so we got y square upon 3 minus c upon y. Okay, so that is how we able to find the general solution. But I think we have more thing they have given in this. No, they are not good. So okay, so that is what we able to solve this question. Now let us try to solve the 12th question now. So we have just solved 11th numericals. Now let us try to solve the 12th. I hope it's clear to everyone. So now let us try to solve the 12th question. Then we have what, we have the 12th question here, that is x plus 3y square into dy upon dx is equal to y, and here y is greater than 0. So they have given this. Okay, so now what we can do, x dy upon dx plus 3y square, but here will also be there. So what we can do, take that side, dy by dx is equal to y upon x plus 3y square. Okay, this is what we have. So now let us see how we can solve this. Okay, I got it now. If I take dx this side, x plus 3y square dy is equal to y dx. Okay, now what we can do, a very simple way, divide by this, x plus 3y square upon y is equal to dx upon dy. Okay, so what we can write, dx upon dy is equal to x upon y plus dy. So I can take this that side, so dx upon dy is equal to 1 is minus 1 upon y, x is equal to 3y. So here we have p is equal to minus 1 upon y, and q we have 3y. So we have now integrating factor, e raised power integration of 1 upon y dy is equal to e raised power minus log y. So we have minus y. Now minus y into y is equal to integration factor of minus y into what is q, 3y dy. So I got minus y square plus c is equal to minus 3 outside. If I take y square dy plus c, I got minus 3y cube by 3 plus c minus y square. Okay, so I got minus y square is equal to minus y into plus c. If I reduce it by y, what will happen? Minus y is equal to minus y square plus 1 upon y to c. Okay, so that is how we able to find the general solution of the linear differential equation. Let us try to solve now the 13th question. Now we have solved 12. Now we have 13th. Let's try to solve here only. We have given the 13th question. We have dy upon dx plus 2y tan x is equal to sin x, dy upon dx. So plus, now we can say p we have 2 tan x q we have sin x. So now what we can do here? Now a simple way, very simple way, we can find the integrating factor now. That is e raised power 2 10x dx. Okay. So now we'll try to find the integration of 10x, that is 2. We have log of, let us find what we have. Now what we can do, that is log of sec x. Now I can write log of sec square x. We got sec square x. Now multiply with it. Sec square x is equal to, we have integration of what? We have integration of that is integrating factor into q. What we have? Sin x dx. Now let us try to solve. What we have? We take 1 sec x is 1 upon cos, so we will have 10x sec x. We will have 10x sec x dx. Why? Its integration will be sec x. Sec x plus c. So I got this, y into sec square x is equal to sec x plus c. Okay. So like this we try to find the solution, but we have one condition, y is equal to 0. So when x is equal to pi by 3, y will be 0 when x is equal to pi by 3. Okay. If I put y 0, it will be 0, and we have x is pi by 3. X is pi by 3. So that is sec 60. Reversal of cos 60. Cos 60 is half, so it will be 2. So c is equal to minus 2. I have not put a value of here because we know multiplying 0 with anything will we have 0. So we have c minus 2. We can put value here. Y sec square x is equal to sec x minus 2. Okay. So that is how we able to solve the able to find the general solution of the linear differential equation. Okay, let us try to solve now 14th question. So now we'll try to solve the 14th numerical. We have the 14th question. 1 plus x square dy upon dx plus 2xy 1 plus x square. They have given y is equal to 0 when x is equal to 1. Okay, let's try to find this. What we can do? Divided by 1 plus x square. So we have 2x upon 1 plus x square. So here we have y and we have, now I am dividing it with this. So I got 1 plus x square whole square. Okay, so now this is what they have given, divided by 2. So now we have p, that is 2x upon 1 plus x square, and q I have 1 upon 1 plus x square whole square. Okay, this is what they have given. So now what we can do, just try to find the first integrating factor. So what is integrating factor? E raised power p dx. So now e raised power p, what is p? 2x upon 1 plus x square dx. Taking 1 plus x square as t and 2x dx is equal to dt. So I got e raised power 1 dt upon t. So I got e raised power log t. So now is what is t here? We have log of 1 plus x square. So we'll have 1 plus x square. So after finding the integrating factor, now we'll try to put in the equation. Okay, so after finding the integrating factor, let us try to put in this y into integration of q. We have that is 1 plus x square whole square into we have that is 1 plus x square dx. So now y 1 plus x square is equal to we have 1 upon 1 plus x square dx plus c. Here we all know that is what we know about it, that is 1 upon integration 1 upon a square plus x square is equal to tan inverse x plus c. Okay, so now we can see here we have given the conditions also that if x is 1 y will be 0. So x is 1 it will be pi upon 4, y is 0 so it will be 0 plus c. So we got c is equal to minus pi upon 4. Now putting value in this we got y 1 plus x square is equal to tan inverse x minus pi upon 4. So that is how we are able to find a general solution of the given differential equation, that is linear differential equation. Okay, so now let us try to solve the 15th question. Now the 15th question they have given, let us see how we can able to solve it. The 15th question we have, that is, now 15th question is there. Now dy upon dx minus dy upon dx minus 3y cot x is equal to, they have given the sine 2x. Okay, sine 2x, and also they have given the condition that is when x is equal to pi by 2, y will be 2. Y will be 2 when x is equal to pi by 2. So now we'll try to put it here. We have p that is minus 3 cot x and q we have sine 2x. Okay, so now let us try to find the integrating factor here, that is e raised power integration of px. We have cot x dx. We know that is e raised power minus log x, log of sin x. Okay, log of sin x we have. So we will have e raised power that will be minus sin x. Okay, so now what we can do here, put here we have already at minus side, so it will be sin x. Now we'll try to put the value here. Q we have, what is q? Q sin 2x, so sin 2x into sin x dx. Okay, so and we have 3 also there, no, minus 3, so it will be cube x. Okay, so now what will happen in a very simple way, y into sin cube x is equal to, put sin x is equal to t. Okay, so that now in this what we have, we'll try to solve this. Now what we can do here in a very simple way, that is we have, so it will be minus cube x is 1 upon sine cube x. So now we'll try to solve this. 1 minus sine cube x, we have this much, we have that is 1 upon sine cube x dx. Okay, so we have y into 1 upon sine cube x is equal to 2 sin x cos x upon we have sine cube x dx. Okay, so y upon sine cube x is equal to, so now we'll have reduced this, so we have to outside, we have cos x, we have sine square x dx. Okay, so now we have this. Okay, if I put now sin x is equal to t, so cos x dx is equal to dt. Okay, so we have 2 dt upon t square. So we'll integrate, we'll minus 2 plus 1, so it will have 1 upon t minus plus here I have y upon sine cube x. So now what we have? Minus 2. What is t? We have 1 upon sine x plus c. And they have said now that is x is equal to pi by 2 when y is equal to 2. So we have 2 upon sine 90. Sine 90 will be 1 is equal to minus 2 upon 1 plus c. So therefore we got c is equal to 4. So now I can put here y upon, so we'll try to put the here. So we have y upon sine cube x is equal to minus 2 upon sine x. So we have minus 2 upon, okay, we have t here, so we have that is sine x plus 4. That is what is the answer. Okay, so that is how we able to find the general solution of the given linear differential equation. Okay, so now let us try to solve another question we have now in a different way. That is, the question says that we need to find the equation of the curve passing to the point 0, 0, okay, whose slope of tangent is equal to the, or that the curve is equal to sum of the coordinates of the point. So we'll have this question: dy upon dx is equal to x plus y. We need to find the equation of the curve that passes to the origin 0, 0, okay. So, and in this they have given anything. In this they have given that the slope of tangent to the curve at that point is equal to the sum of the coordinates of the point xy. So now we'll try to solve this equation we have. Now the equation given is dy upon dx minus y is equal to x. So we have p minus 1 and q we have x. So we have the integrating factor e raised power, we have the integrating factor that is e raised power p dx integration. So we have e raised power minus x. So now multiply with it. So we have e raised power minus x into y is equal to integration of q. Okay, so we have integration of q into e raised power minus x. Okay, see. Okay, so now let us try to solve this, taking this as first function, this as second function. So we'll get x into integration of this minus, we have differentiation of first function x, integration of, so it will be e raised power minus x dx. So we'll have minus x e raised power minus x minus e raised power minus x plus c. Now we have this. Now they are saying they are passing to the origin. So x and 0 will be, x is equal to 0 and y is equal to 0. So we have whole will be 0. It will be minus 0 into e raised power 0 minus e raised power 0. So it will be what? Whole 0, but it will be e raised power 0, 1 minus, so c is equal to 1. So putting this value here, I got y e raised power minus x is equal to minus x e raised power minus x minus e raised power minus x plus 1. Okay, I can put here also. So we have y is equal to e raised power minus x. So what I can do here, y upon e raised power x is equal to minus x upon e raised power x minus 1 upon e raised power x plus 1 upon e raised power x. Okay, so I have this. Now what I got this here is y is equal to this, so we will have this. Okay, so we can, if I multiply here, okay, now I e raised power x is, so this is only one we have, no? So now we'll have this What you can do, you can multiply with this. So we get y is equal to minus x minus 1 plus e raised power x. Okay? So that is how we able to find the general solution of the equation given by the curve passing through the point 0, 0 and whose slope of tangent at that curve is given by the sum of the coordinates of that curve passing through the point. Okay, so that is how we are able to solve this. Now let us try to solve one more question. We have solved 16 now. Now we'll try to solve this 17th. Now we have the 17th question here. So 17th, let us try to solve this. Now let us try to find the equation of the curve passing through the point 0, 2, and they have given that the sum of the coordinates of any point on the curve exceeds the magnitude of the slope of tangent by 5. Okay, so this is a question I had. So now we'll try to solve this. Now they have dy upon dx is equal to x plus y. So we will have dy upon dx minus y, okay, is equal to x minus 5. So now here p is minus 1 and q is minus 1 and q we have, what is that q? Q we have x minus 5. Q we have x minus 5. Okay, so now let's try to find the integrating factor is equal to, we have the integrating factor that is e raised power minus dx. We'll have e raised power minus x. Now we'll try to solve this. E raised power minus x is equal to, what we have, q, x minus 5, e raised power minus x dx. So now e raised power minus x is equal to first second function. So first function is, we have this x minus 5, integration of this will have minus e raised power minus x minus differentiation 1, integration of that will be e raised power minus x dx. So we have x minus 5 minus e raised power minus x minus e raised power minus x plus c. Okay, so now you have this, we can reduce this. So we got y e raised power minus x. So we got y is equal to minus x minus 5 minus 1 plus c. Now they are saying that is passing from the 0 to, so x is 0, y is 2. Y is x is 0. So plus 5 minus 1 is equal to, oh sorry, we have c. So now 2, 4 plus c, so c is equal to minus 2. Okay, so now what we can do here, we have c is equal to minus 2, we can put the value here. So I got y is equal to minus x minus 5 minus 1 plus we have minus 2. So we have minus x minus 5 minus 1 minus 2. If I solve it further, I got minus x plus 5. Okay, minus x plus 5 minus 3. So we got y is equal to minus x plus 2, or x plus y is equal to 2. That is what I got my answer. Okay, so that is how we able to find the general solution of the given linear differential equations. I hope it's clear to you. If you have any doubt, you can comment, you can ask, you can share, and also please like my channel. Thank you.